Yellowstone's alert level is currently green, but don't get too comfortable. This supervolcano is still alive, and it could erupt at any time. New data shows the caldera is breathing, with the ground slowly rising and falling as things move deep underground. If Yellowstone actually blew today, it would be a huge disaster. A 10-foot layer of ash would bury everything as far as 1,000 miles away, and over 90,000 people would lose their lives almost instantly. Now, the problem is there's some strange activity going on there lately, like the rare Aquinas geyser erupting all of a sudden. This is the biggest acidic geyser in the world that measures about 60 feet across. Think of it as a hot spring that shoots up acid. It's also scorching hot, with temperatures that can get over 200 degrees Fahrenheit. The Aquinas geyser was really active back in the 70s, and it used to erupt every 40 to 80 minutes. But it stayed quiet for the last 6 years until it erupted again in February 2026. The water shot 30 feet high and the eruption lasted about 3 minutes. It was quite a show, but people were worried. I mean, is this a sign the volcano is finally waking up? Well, probably not. Geysers turn on and off all the time. That's just typical Yellowstone behavior. But Aquinas isn't the only hot spring out there that's been acting a little weird lately. So, Yellowstone was the first national park in America, and it sits right on top of an active supervolcano. That's why there are over 500 active geysers over there. Basically, they're hot springs that get heated up underground and shoot water and steam into the air every so often. These geysers are shaped like a long tube or a hole that goes deep into the ground and fills up with water. Since the water at the very bottom is so close to the magma or molten rock, it starts to boil. That pressure forces the water up and out in an eruption. Then the water slowly drains back down and the process starts all over again. Having all these geysers around means the park is basically covered in steam, so it has this really mysterious, misty feel to it. And now it just got even cooler. The ground is literally moving. Lately, everyone's been focused right here, on the Norris Geyser Basin. This spot is home to the Steamboat Geyser, the tallest active geyser in the world. And since 2025, scientists have noted something weird here. The land, which used to be flat, now has a bulge in it. Yep, the ground has pushed up by about an inch along the northern rim of the Yellowstone caldera. But we don't have to worry about Yellowstone finally erupting and destroying the planet. I mean, the situation is pretty scary, sure, but it's not a direct sign that an eruption is on the way. To be fair, this is not even a new phenomenon. Between 1996 and 2004, the land did the exact same thing. The area just south of the Norris Geyser Basin rose by almost 5 inches. This happened because a huge pool of magma, about 9 miles deep, was pushing up from underground. It felt like Yellowstone was ready to erupt at any time. Everyone was terrified, thinking it was the end of the world. But nothing happened. Then, in late 2013, the ground started rising again, at a rate of about 6 inches a year. And that was faster than ever before. Everyone got super nervous all over again. But just like last time, nothing big happened. The event lasted until 2014 and ended with an earthquake with a magnitude 4.9. That was actually the largest one in the area since the 70s, but it didn't trigger a massive eruption. In fact, the last time Yellowstone actually erupted was about 70,000 years ago, and it was not even a huge blast. Now, the area where this happens is known as the Norris Uplift Anomaly, and scientists are getting pretty used to its strange behavior. They say that when magma moves into the Earth's crust, it cools down and releases trapped gases. As that gas escapes, the pressure drops and the ground sinks back down. But just when we thought the area was finally quiet, nah. Back in July 2025, scientists checked the data and confirmed it. The land was rising again. The whole process looked very similar to the one back in the 90s. This might also explain the sudden rise in the number of earthquakes in 2025. I mean, the year was actually pretty quiet overall, with only about 1,100 earthquakes. That's pretty low, considering that at least 1,500 happen in a normal year. But the number of earthquakes suddenly went up at the end of 2025, and most of them happened right near the anomaly. So scientists were pretty sure the two things are connected. According to the estimates, it looked like the ground was going to keep rising for a while. But they also said we don't need to worry about an eruption. The changes we've seen so far are actually pretty small. They're nothing compared to the warning signs we'd get if Yellowstone was really about to blow up. Plus, we have way better tools now than we did in the 90s to track all these ups and downs. But one thing we know about volcanoes is that they are unpredictable. So against all the projections, something strange just happened. The ground stopped rising. Exactly. Recent measurements show the upward movement that had been happening since July 2025 has paused. So, whatever was going on under the Norris Geyser Basin just ceased, for now at least. Then there's something else that shows the caldera is back to normal. In February 2026, there were 74 earthquakes out there, which might sound like a lot, but for Yellowstone, it's not. That's a pretty standard number, because about half of the earthquakes in the park normally happen in swarms. I mean, groups of quakes that hit the same spot around the same time. And these swarms can trigger 10 tiny quakes in an hour, for example. To give you an idea, the year with the most earthquakes was 2017. That year, we were seeing something like 285 earthquakes a month. And even then, that wasn't considered dangerous activity. So, if February only had 74 quakes, we can consider it supernormal. Okay, so the caldera looks like it's quiet again. Does that mean we're safe and Yellowstone won't blow up? Not really. Then again, volcanoes are totally unpredictable. Yes, I'm repeating myself. But even with all the high-tech tools we have today, we don't exactly know how they will behave. So, technically, it can erupt at any time. Now, some people might think that Yellowstone is overdue, but that's not really how it works. If you look at the map, there's an average of about 725,000 years between its big eruptions. Based on the last time it had a big blast, we've technically got another 100,000 years left. But honestly, that average doesn't mean much, because volcanoes don't follow a schedule. Now, if Yellowstone did blow, it would be a total disaster. Some say it would be way more powerful than anything humans have ever seen. Computer models show it would blast tons of ash and toxic gas into the sky, making it almost impossible to breathe. That ash could even reach Europe in 3 to 4 days. The magma would completely wipe out the region, swallowing up forests, rivers, mountains, and anything else in its path. But scientists say the chances of an eruption are super tiny. And there's more. One of the magma chambers under Yellowstone is only about 5 to 15% liquid. The rest is basically solid rock. Hot rock, but still. It's not even clear if there's enough runny magma down there to cause an eruption in the first place. Anyway, that doesn't mean we should completely relax. Experts are still keeping an eye on the North Geyser Basin to see if anything changes in the coming months. Actually, the whole volcano is constantly monitored, and this situation is just another reminder that Yellowstone is still very much alive. It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hot spots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now. But scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain 2 parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the 2 of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
Yellowstone is the internet's favorite doomsday volcano. Maybe you heard the prediction. One super eruption, then a continent dusted in ash and temperatures going down. A perfect disaster movie scenario. Yet, geologists worry about a different kind of volcano. One that won't explode only once. It could rip the ground open, flood the entire continent with lava, and make the air unbreathable. And we know this because it happened before. Right now, researchers think there might be around 20 supervolcanoes scattered across the planet. Short story, we fear those. Long story, a major supervolcanic eruption could collapse modern society as we know it. A normal volcano can cause a local disaster. It can wipe out a city and turn a region into a no-travel zone. When Mount St. Helens exploded in 1980, it was huge. The eruption blew the top off a mountain and flattened forests like knocking down dominoes. It showed the world just how scary volcanoes can be. But in geological terms, it's nowhere near what a supervolcano could do. Mount St. Helens threw out roughly a third of a cubic mile of ash, enough to make a football field pile about 150 miles high. For comparison, a supervolcano could bury the entire state of Texas 5 feet deep, and Texas stretches about 800 miles. Volcanoes like St. Helens are mountains that build up over time, layer after layer, like nature stacking spilled wax. They erupt, they cool, they erupt again, and you end up with a cone that looks cool in photos. A supervolcano is like a hidden pit. It resembles a giant underground tank of molten rock covered in a thick slab of crust. Imagine the magma chamber like a huge underground room, and the ground above it is the ceiling. During a super eruption, cracks rip open across that ground and magma forces its way up through them, like steam blasting out of a pressure cooker. Ash and gas roar high into the sky. It can start in multiple spots across a wide area, not one neat hole. The magma chamber underneath can empty so violently that the roof above it collapses, the land drops, and what's left is a massive bowl-shaped scar called a caldera. And Yellowstone is the prime example. About 631,000 years ago, Yellowstone had a massive eruption and it left behind a giant caldera about 30 by 45 miles across. Now it's a national park, but it's also basically a footprint, like a warning. If Yellowstone erupted again, the first super hot clouds of ash and gas could blast outward and burn everything nearby. Then the ash would spread. And ash is not like the fireplace dust. It hurts to breathe. It wrecks engines, and it can shut down flights and machines. Regular volcanoes mostly hit the area around them with lava. A super eruption turns the air itself into a real danger. Ash spreads far and jams the things we depend on. High up, sulfur can turn into a thin haze that will block some sunlight. That can cool things for a while and mess with growing seasons, even far from the eruption. And winds can spread that effect well beyond the US. However, geologists worry about something even worse. A kind of eruption that can keep going in waves and cover huge regions in lava. It's called a large igneous province. It's not one volcano, it's a whole stretch of crust that starts leaking lava through long cracks over and over for a long time. Instead of one giant explosion, it's more like Earth turning on a lava faucet that just keeps going. Imagine a crack in the ground hundreds of miles long. Out of that crack comes a sea of lava, but this isn't the sticky, slow stuff you see in Hawaii. This is hot, runny, fast-moving lava, and it doesn't stop. It spreads, floods low spots, stacks into layers, and then does it again. And that's what makes LIPs scarier than a supervolcano. They drag on. They can erupt in repeated pulses over hundreds of thousands to a few million years. We have scars to prove it right here in the US. About 17 million years ago, the Pacific Northwest ripped open and created the Columbia River basalt. Lava did not just coat the land, it drowned it. The total amount that erupted was around 42,000 cubic miles. That's enough to cover the whole US in lava about 58 feet deep. But how can Earth produce enough lava to bury a mountain range? It's because the planet is still churning inside. Imagine Earth like a pot of thick tomato soup sitting on a stove. Earth's core is the stove, and it's extremely hot. The soup is the mantle, a thick layer of rock that moves slowly. Now and then, a massive blob of superheated rock rises from deep in the mantle, possibly from the boundary above the core. Scientists call this a mantle plume. When it reaches the cooler crust, it spreads out, pushes upward, and when it breaks through, it does not build one neat mountain. It can open long cracks and feed eruptions in repeated bursts for a very long time. However, while lava burns everything in its way, it's not what wrecks the planet. The gas does. These eruptions release huge amounts of carbon dioxide and sulfur, and we can assume the consequences of that because it happened before, and not just once. About 252 million years ago, a massive LIP eruption began in what is now Siberia. It lines up with the worst extinction event in Earth's history, the Great Dying. Around 90% of species disappeared. Huge amounts of gas flooded the air and trapped heat. The ocean soaked up some of that gas and turned more acidic. Acid rain fell again and again. Life on Earth crashed. Scientists believe that in the last 500 million years, there have been 16 major extinctions like this, and that 15 of them line up closely with LIP timing. These geological formations changed Earth so many times, and scientists now wonder, what if Yellowstone and that massive lava flood in Oregon are actually a part of the same system? Look at Idaho from space, and you see a long, flat track across the state called the Snake River Plain. It points from the old lava flood region toward Yellowstone, like a trail. That path exists because Earth's surface moves. The outer layer is split into giant plates that slowly slide. Under Idaho and Yellowstone, a deep, hot zone keeps feeding eruptions. As the plate moves, the eruption zone shifts with it, leaving a long trail behind. That's why the rocks get older the farther you go from Yellowstone. It's the same heat source, just a moving target. And if you roll the plate's motion back far enough, that trail points closer to where the Columbia River basalts formed. That's why some geologists think the Northwest lava flood and Yellowstone could be connected parts of one long-lived system. Finally, if it's all part of one big apocalyptic system, is it time to pack the bags and flee to Mars? Will it happen again soon? Even if they share the same story, that does not mean the worst part is coming back soon. The lava flood chapter played out millions of years ago. Today, Yellowstone is simply where that deep heat shows up at the moment. And sure, it can erupt again, but the most likely eruption isn't some giant doomsday blast. It's a steam explosion, when super hot water flashes into steam and blows rock apart. Lava flows and smaller eruptions can happen too. The caldera-making nightmare is a rare one. If Yellowstone ever started building towards something big, it wouldn't be sneaky. You would see it coming. A lot more earthquakes than normal and the ground lifting faster than usual. The clearest right before signs would likely show up in the days or weeks before it. We cannot stop a planet-scale eruption. We can only watch for the warning signs and plan. But hopefully, if the planet decides to get rid of us, by the time it starts sending warnings, we'll already finish turning Mars into our new home. It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ashen clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another, like falling dominoes, one by one. Terrible times await Earth, and okay, stop. It's clear, we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them. For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who's nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads. everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray, hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. Human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life. Be grateful and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hot spot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called Mushroom Pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus Aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, Several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's a reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about two other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the two is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hot spot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius. that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows. Dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by two previously unknown supereruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a supereruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 supereruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight. Being afraid of the ocean is a very understandable fear. We have it in our genes. In the past, humans had to avoid certain dangerous situations, like big animals and deep bodies of water, in order to survive. Plus, we've only explored 5% of the oceans, so we never know what we can stumble upon there. In regular conditions, GoPro is just a camera. But if you find it lying at the bottom of a 400-foot pit in the middle of the Caribbean Sea, that will make your blood run cold. I know 400 feet may not seem like much, but a person who is deep diving for fun usually can swim from 59 to 98 feet deep only, unless they're a professional diver. But say you made it to that pit and retrieved that GoPro. That would have still been fatal to you. In this specific hole where the camera was found, there would be a layer of hydrogen sulfide, a very dangerous and foul-smelling gas, at the mark of 300 feet. The gadget was 100 feet lower, alongside its owners, 2 long-lost explorers. To this day, very few people managed to dive this deep and go back unscraped. In fact, the deceased explorers were found only with the help of submarines. Now, you might be curious about the content of the GoPro. In stories like this, we expect proof of foul play or sinister footage. But the only thing found there were the images of happy times the explorers had during their trip. A sad ending to a vacay. Now, in deep waters, you can also find many species that seem to be otherworldly, but in a cute and interesting way, like the alien sponge. This fun little fella is a sponge first seen near the Mariana Trench in 2016. It's actually part of an ecosystem dubbed Forest of the Weird. Okay, this makes it sound a bit creepy. And what adds to the weirdness is the fact that the alien sponge had two little holes that resemble little eyes, so like it's peeking at you. Ah, another fun fact? The skeleton of this type of sponge is made of glass. And if you're afraid of cockroaches, I'll let you take a deep breath here. Ready? Cool. Because on the ocean floor, there are more than 20 different types of giant isopods, beetle lookalikes, that can be as big as 14 inches. Yikes! But fear not, these guys usually roam the ocean floor for food. So, unless you dive 7,000 feet, which we've just seen is not possible, you won't run into them. Now, despite the horror movie name, the bloody belly comb jelly is actually a fascinating creature you can also find in the ocean. They live in the twilight zone of the ocean, which is between 820 and 4,900 feet below sea level. Pretty far from where you usually soak your feet. But what's so cool about this jelly is its color. Because in the twilight zone, the light is very scarce. Many animals either emit a faint glow, like the anglerfish, or create a camouflage. The jelly here is blood red because, in the pitch-black darkness of the ocean, other animals won't see it digesting colorful bioluminescent prey inside its stomach. Besides, the jelly has a row of combs that spark a very beautiful iridescent light. Beautiful and lethal. Humans also have their fair share of contribution to the weird fest that is the ocean floor. Depending on where you swim, you might just find parts of rocket engines used during the Apollo program. Now, when a rocket is launched into space, parts of it are dropped into the ocean where it runs out of propellant, making the rocket itself lighter. And a part of the Apollo 11 rocket engine, yes, that one that first took humans to land on the moon, was actually recovered from the ocean after more than 4 decades. And you can see it at the Museum of Flight in Seattle. Not a space fan? Well, there's something for the Oregon Trail lovers too. There are 2 locomotives living their best lives, or worst, depending on your point of view, just off the coast of New Jersey. They're from the 1850s and are sitting under 90 feet of water. They probably fell off of a transportation ship during a rough storm, or were intentionally pushed over the barge so that the ship didn't sink. Most of these things can only be seen while diving, but worry not. Even if you have a lingering fear of the deep ocean, you can still find weird things by simply walking on the beach. Look at these bizarre Garfield landline phones washed away in Brittany, France. The French have been having bizarre encounters with the sarcastic orange cat since the 80s, and it took about 30 years for French farmer René Morvan to come forward with a simple explanation. A shipping container with Garfield merchandise got stranded in the sea, only to find its final resting place in a sea cave. We bet Brittany locals are still haunted by the creepy smile of that landline phone. And just like a storm uncovered the Garfield secret stash, it also moved a few ships that sank more than 600 years ago. But this is not a simple Titanic story. It actually sounds more like Pirates of the Caribbean, because when the storm moved those old ships, authorities from Caesarea found 2,000 gold coins, some silver and bronze coins, gemstones, and rings. It was a bigger treasure than a dragon could hoard. But don't get your hopes up. Even though most of the underwater archaeological zones in this region are open to divers, these treasures are safely tucked away in a museum. Speaking of pirates, and I was, another weird thing you can find chillin' in the ocean is the pirate city of Port Royal, Jamaica. In 1692, the city was devastated by an earthquake, followed by a tsunami. A really bad twofer. But the good news is, you can still visit it today, while scuba diving, that is. This is actually not the only sunken city in the world. There's also Thonis Heracleion in Egypt, which is not at the bottom of the sea per se, but at the mouth of the Nile River. There's also Baiae, a Roman town built atop a supervolcano. Now, you might be thinking Baiae had the same fate as Pompeii, but guess what? The floor actually sank and the town went down with it. So, have you ever heard of underwater crop circles? Back in 1995, divers in Japan spotted perfectly round circles formed in the sand. They were 6 feet in diameter and looked like those crop circles from sci-fi movies. Scientists simply couldn't figure out what or who did it until they caught the culprit red-handed, a tiny male pufferfish only 4 inches long. This little guy uses its body and fins to draw circles and squiggles and decorates his creation with seashells and corals. It takes the fish about a week to do so. All this hard work is part of a mating ritual, and if a female pufferfish likes the art, she will lay her eggs there, right in the center. The circular design of the underwater crop circle actually channels fresh water to the middle of the circle, the ideal scenario for the eggs to develop. And guess what? After she lays the eggs, the female pufferfish leaves, and it's the male that tends the eggs. But just in case fishes are not your thing, we can also offer you a cargo of rubber duckies, turtles, beavers, and frogs, 28,000 of them to be exact. These bath toys were traveling from China to the US, but much like our friend Garfield, were caught in a storm in 1992. From the North Pacific, our friendly duckies and beavers made their way to the UK by 2007. But some were bolder and traveled to Australia, Indonesia, Chile, Hawaii, and even Alaska. Now, have you ever seen a strange thing washed up by the beach? Let us know in the comments. Bye. Consider Lake Enigma. What a fitting name. It's already strange enough because it's not even supposed to exist. But now, we stumbled upon actual life deep beneath it. And this just might help NASA in their search for life in outer space. The lake lies deep in the icy heart of Antarctica, so it's not really a water pool like we're used to, more like a lake-like block of ice, or so we thought. Just recently, Italian scientists discovered a secret that had been buried for ages, an actual body of water, and in this water, life is thriving. Various microorganisms, and even some weird little hunters. Which is super weird, since Enigma sits in a remote and harsh corner of our planet, the northern Victoria Land in Antarctica. The entire South Pole is cold, but in this place, temperatures can plummet to a horrifying minus 41 degrees Fahrenheit, though on average it's around 7. Chilly. Like we said, this lake shouldn't even be there at all. Antarctica is technically the largest desert on Earth, even though it's covered in snow, because it's super dry. There are 0 rains, truly little snowfall, and the sun barely evaporates anything. And even if there is some water, the insane winds make sure to dry everything out super quickly. Putting on our thinking caps, this lake should lose an unimaginable 7 million cubic feet of water every year. Yet, the water remains. Why? No one knows. Scientists say there could be something deep underground that refills it constantly. They just have no idea what that might be. Maybe deep underground rivers, melting ice, or something else entirely. But hence the name, the Enigma Lake. The block of ice we mentioned is permanent and super thick, at least 36 feet of it, and that's higher than a 3-story building. So researchers decided to check out if there's anything beneath it. They used a so-called ground-penetrating radar, a super smart echo detector for the ground. This radar sends invisible radio waves into the Earth. When they hit something underground, like rocks, water, or anything else, they bounce back to the device. By measuring how long it takes for the signal to return and how strong they are, we can determine the distance and what exactly the radar hit. That's how animals like bats, whales, and dolphins can see underwater. And we humans stole this cool nature idea to research buried structures and hidden caves. Scientists used this device all over the Enigma surface. This way, they were able to create an entire map of this under-ice world beneath. The water itself wasn't surprising. It's the unique ecosystem in it that shocked them. Unfortunately, no secret monsters or extraterrestrial secrets this time. But there are microorganisms there that may not exist anywhere else on Earth. Somehow, these creatures have managed to survive in complete isolation and extreme cold. It's not that we don't know these microorganisms, we've met them before, just not exactly like this. There are a couple groups hanging out down there. The first one is Bacteroidota. They love breaking down complex molecules, especially in your stomach, and help digest tough plant fibers. They mostly hang out inside us, but in the outside world, we might occasionally find them in soils and oceans. Then Actinobacteriota, genius chemists among bacteria. They decompose organic materials and help the soil get healthier. They're also famous for producing antibiotics, so we owe a lot of our medicine to them. The third one is Pseudomonadota. These guys weren't a surprise. They're crazy adaptable. They can thrive pretty much anywhere, from soil to water to the human body. Some of them are good, helping plants grow and in nutrient cycles, but others can be opportunistic pathogens. Ooh, bad guys. But what is actually a surprise is that Lake Enigma has tons of passibacteria. They're ultra small even for microorganisms and can barely do anything themselves. So they prefer to live in symbiosis or be little parasites, relying on their hosts for nutrients and other necessities. All these little chompers might be ancient. They could be remnants of a time before the lake froze over completely, which is hundreds of thousands of years ago. It's simply weird to encounter these bacteria in the Enigma Lake, especially the little parasites. Passibacteria usually love low-oxygen environments, but this lake is very oxygen-rich, not even mentioning an almost 40 feet of ice above. So all this means that even though we know who these guys are, this specific species might be new to us. They could have evolved with some unique adaptations and abilities using the lake's unusual chemistry. They probably rely on a super simple and delicate food web. Some of the microorganisms produce energy from light, well, whatever light gets down there, or the lake's chemicals. The symbiosis guys most likely survive by living on or inside their neighbors. Yep, these microscopic creatures hunt each other. Nope, things can't be peaceful even in a place like that. If we find out what their secret to survival is, we might learn more about chemistry, medicine, and even extraterrestrial life. Because if life can endure such extreme conditions, then it can probably appear pretty much anywhere, including our closest neighbors, Europa or Enceladus, the moons of Jupiter and Saturn. They definitely hide oceans beneath their frozen surfaces, and now there's a very high chance there might be some life there. Antarctica must be the closest thing we have to extraterrestrial exploration before we actually land on other planets. It's full of hidden mysteries and surprising creatures. Even outside of Lake Enigma, the South Pole harbors life. Just take the McMurdo Dry Valleys, which are often referred to as Earthly Mars. These are among the most mysterious and extreme places on our planet. They're stretching across Victoria Land in Antarctica, and this is one of the driest places on Earth. Makes sense if you remember the name. Surprisingly, unlike other parts of the South Pole, this land is almost entirely devoid of snow and ice, just lots of super cold ground. There might even be some sand dunes nestled here and there between the rugged mountains. The ground is mostly covered in loose gravel, scattered with ancient rocks made of granite, and something interesting called gneiss, just spelled differently. It's the type of rock that's been through a lot, literally. It's usually born when granite and sedimentary rocks have to endure insane pressure or horrifying heat for a while, a process called metamorphism. These conditions are so intense that they literally rearrange the minerals into layers. That's why gneiss has such beautiful foliated looks. It's the planet's version of baking a layered cake. It's amazing because this place is almost exactly the way it was millions of years ago. These valleys are frozen in time, and they give us a little glimpse into Earth's distant past. And that includes life. Once again, local winds are absolutely terrifying gusts of cold air racing downhill, and they evaporate snow faster than it can even melt. So, logically, you shouldn't find much water here, not even mentioning life. But somehow, you can still stumble across frozen lakes and saline ponds in the dry valleys. And local life stretches all reason and our understanding of biology. It exists inside the rocks themselves. Microorganisms are hidden in slightly moist cracks and crevices. Deep inside, there's endolithic bacteria. These guys are super chill. Instead of moving around like other microorganisms, they always stay put inside their little rocky homes. How do they survive? Through photosynthesis. Just like plants, they take teeny tiny parts of light that gets in crevices and acts like little solar panels, getting energy from the sun. Meanwhile, in another place, beneath the Taylor Glacier, there's bacteria that literally doesn't eat anything. Not comfort, not sunlight, not even oxygen. These guys rely on a diet of dusty rocks and sulfur to fuel their weird metabolisms. By breaking down sulfur and iron, they get energy to sustain themselves. This way, they easily survive in deep seas at sub-freezing temperatures, completely cut off from sunlight, oxygen, and the world itself. This place is fascinating for both its life and the lack of it. In some parts of the valleys, like University Valley, yes, that's what it's called, the permafrost is so harsh that no microbes were found at all. This might be one of the only places on Earth where life appears to be completely absent, a quite scary idea. Anyway, now scientists are thinking about learning more about Lake Enigma and drilling this Mars-like environment, exactly for that reason, to see how we could get samples from Mars in the future. Now see here, astronomers have recently discovered a neutron star, also known as a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe. And it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 12 miles wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy release from such impacts is truly astonishing. Now, despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Now, normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like a neutron gnagi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going any deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So, inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penne pasta. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system located in a dense star cluster. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second, but a minute, it'll be over 42,000 revolutions per minute. At the same time, the newbie ties with another neutron star, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system, with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. So, you might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. No, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star surface, eventually. It triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than our Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and thus confirmed its extreme rotational speed. But wait, the best part is coming. While neutron stars are already extreme, there's another class of them that takes things to a whole new level – magnetars. Now, magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it's so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by star quakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma-ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma-ray bursts from across the universe, didn't just detect the blast. It got hit with so much energy that its sensors got completely overloaded. And SWIFT wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar was located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. Whoa, that's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy. Neutron stars and magnetars serve as laboratories for extreme physics. They allow astronomers to have insights into the behavior of certain matter under conditions you can never replicate on Earth. The incredible density of these objects helps scientists figure out what happens when protons and electrons get compressed together to form neutrons. This creates states of matter that don't exist anywhere else in the universe. These violent explosions on neutron stars and magnetars also play a critical role in the formation of heavy elements like gold and platinum. These elements get scattered all over the universe during these energetic events, eventually becoming parts of planets and stars and you and me. Oh, by the way, NASA's NICER instrument has played the key role in uncovering the mysteries of neutron stars. Its ability to detect X-rays with high precision allowed astronomers to study the rapid spin of the neutron star we've been talking about and the thermonuclear bursts that occur on its surface. So, what could be nicer than that? It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour, so it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest a storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.
The South Pole is more than penguins and endless snow. There's a hidden ghost world within it. Look, it's right here on the globe. Don't confuse Antarctica with the Arctic, which is at the top of our maps. Much smaller in size, and, let's face it, way less mysterious. The ice sheet covering Antarctica is about 1 to 3 miles thick, which is up to 16 Eiffel Towers stacked on each other. This massive blanket hides the true features and contours of Antarctica's land. We still don't know much about this mysterious continent, and it is ice and snow that are to blame. We still don't even know the true shape and size of this continent. Mapping Antarctica without some huge shovels is an incredibly hard task. But satellites learned to penetrate the ice with their cameras. And now we know there's actually an enormous, dramatic ancient landscape beneath the snow. The ghost of the past. About 90 million years ago, Antarctica was a much warmer place. It was actually a lush rainforest with tons of plants and probably teeming with life. It even had rivers flowing through it. Then the ice came. This happened about 34 million years ago, during the transition from the Eocene to the Oligocene, when our planet cooled significantly. It was the beginning of one of our several ice ages. The land remained, but now was hidden under ice and snow that got thicker and thicker. To a regular eye, Antarctica turned into a white desert, vast, flat, and featureless. Time went on. This massive ice sheet moved around, smoothing and shifting the ground beneath it. Over the millions of years, it changed what the land looked like. Now, if we looked under the ice, it wouldn't hold any signs of the original South Pole, except for one place. In areas where the ice is especially thick and doesn't move much, like in East Antarctica, it has actually worked the other way around. It became like a super thick blanket that protects the land. Normally, things like wind or rain slowly wear away the ground over time, changing its shape. But since we have this protective ice blanket, it prevents these natural processes from reaching the stuff underneath. So, the ground stayed almost the same for millions of years, like it's been frozen in time. This special area near the Aurora and Schmidt subglacial basins has become the ghost of Antarctica's landscape. This place was barely touched even since it was first covered in snow 34 million years ago. This is a historical footprint, a place that can tell us what Antarctica's ground looked like before it became a freezing nightmare. As scientists peered under East Antarctica, they saw an amazing ghost. The traces of the rivers that were flowing there millions of years ago, various valleys, and some weird little islands, as well as 3 big chunks of land shaped like the letter U. Hey, what's that all about? You see, the continents on our planet are moving constantly, sliding along the red-hot lava mantle like cereal on milk. Over history, they came together and broke apart several times. Hundreds of millions of years ago, several continents were a part of one enormous Gondwana. Antarctica was one of them. It used to be one huge landmass. But when Gondwana broke apart, the poor continent got stretched by tectonic forces. Parts of land were pulled away from each other. Whoosh! And they got torn apart. And that's how we got these big chunks or blocks of land under thick layers of ice. In any case, scientists now want to explore this ghost a bit more. But to study it deeply, they need to actually drill down through the ice, like using a straw to get to the bottom of a thick shake. This will help them pick up some rocks and dirt from way below to learn more about the Earth's history and climate. Antarctica is the 5th largest continent in the world, approximately bigger than the entirety of Europe or Australia, competing with the entire South America in size. Aside from East Antarctica, we discussed there are several more regions: Antarctica Peninsula, South Pole, West Antarctica, and the Ross Sea. The continent is basically a frozen sandbox, and all its hidden, mysterious landscape is actually less explored than Mars's terrain. We only know for sure that without ice, it wouldn't just be flat and empty, but an entire world full of big mountains, huge canyons, and even fiery volcanoes. Some of these volcanoes are so huge that they peak above the layers of snow. In West Antarctica alone, there are at least 138 volcanoes, though only about 8 or 9 are active today. One of the craziest ones is Mount Erebus, the southernmost volcano and the tallest one on the continent, about 12,500 feet high. And deep beneath the ice sheet, this guy hosts incredible, beautiful subvolcanic caves. The temperatures there are warm enough for t-shirts. The Antarctic Peninsula, or Lesser Antarctica, looks like a bunch of mountainous islands deeply underground. It has newer volcanic rocks that are part of the Pacific Ring of Fire, which is like a giant circle of volcanoes and earthquake zones around the Pacific Ocean. The Greater Antarctica is a huge part, almost as big as Australia. It consists of East Antarctica and the South Pole. Beneath the ice, it's a place of rocks that have been around for a very, very long time, including the special zone we mentioned. You probably know that Antarctica is nearly devoid of humans. No wonder, with a mean temperature of about -46 degrees Fahrenheit. But even though this place is horrifyingly cold and deserted, life still clings on. You guessed it, in the underworld. In 2017, scientists found DNA traces of algae, moss, and even possibly unknown small animals in the deep caves. That means that even in such crazy conditions, there are still unique ecosystems thriving in little isolated warm pockets beneath the snow. There was another incredible find beneath Antarctica's Ross Ice Shelf, a lively ecosystem vibing within an underground river. Scientists have long suspected that Antarctica's underworld should have some freshwater lakes and rivers. One day, a satellite spotted a groove there. They decided to explore it and used a hot water drill to melt their way through the ice. As they reached the underworld, they dropped a camera into one of those hidden fresh rivers. And at first, they thought they'd find just some rocks or something. But instead, they stumbled upon hundreds of amphipods, tiny shrimp-like creatures. Little ones instantly swarmed around the lens. Shrimps blocked the camera and scientists couldn't check out what they wanted to. Pretty funny, but at least that means that there really is an important ecosystem deep within Antarctica. Now, they're gonna explore it. And all this is just the beginning of the mysterious underworld. Antarctica's snow also hides the deepest canyon on Earth under the Denman Glacier. Well, Mariana Trench is still the deepest point on Earth, but it's a part of the oceanic crust, geologically speaking. Also, in 1958, explorers found a huge mountain range under the ice, as big and tall as the famous Alps Mountains. The range stretched for about 745 miles with peaks as high as 1.7 miles. And all this magnificence is buried under tons of ice. Who knows what else we might find there? Antarctica holds about 60% of our entire planet's fresh water, which means it would be pretty bad if it melted. For example, there's this Doomsday Glacier, officially known as Thwaites Glacier. It's a huge ice formation, about the size of Florida, and it's melting right now. Every year, the sea levels rise by 4% because of it. If this guy melts away completely, the sea levels all around the world will increase by 2 feet, which might not sound like a lot, but it would be catastrophic for coastal areas. Luckily, researchers have found that even if its ice shelf were to collapse in the next 50 years, the glacier itself wouldn't retreat as quickly as they feared. It's still losing ice rapidly, but it would be quite a slow process. Salt makes our chips and popcorn taste yummy, but it turns out that's not all. It's used in household and industrial products, from cosmetics to fertilizers, from water treatment to road gridding. All over the globe, around 300 tons of salt are produced every year. But there's a problem. That's too much salt for our planet. You see, salt rises to Earth's surface from deep oceanic rocks gradually, and this process is quite balanced, or it used to be. Humans are pushing this balance out of whack. Our demand keeps increasing, and we're releasing too much salt into the soil, air, and sea. And if this process continues unchecked, we might face an existential threat. Yep, it's as serious as that, and a recent study conducted by the University of Maryland confirms this. There is this thing called the natural salt cycle. It's existed for thousands of years. Salt naturally rises to our planet's surface via geologic uplift and rock weathering. Sometime later, rocks break down and release salt ions into the soil. Some of these ions are absorbed by plants and organisms. Others are washed away into rivers, which transport them into oceans. Salt also gets into the atmosphere. It happens through salt dust in dry regions and sea spray in coastal areas. It's crucial for humans because our bodies need salt, just like animals and plants do. Simply put, we're electrical systems controlled by salt. Soil needs salt because otherwise it won't clump together. Plants also need small amounts of salt since those allow them to have proper metabolism and synthesize enough chlorophyll. At the same time, too much salt isn't a great thing, and nowadays, human activity is messing with the natural salt cycle, bringing salt to the planet's surface much more quickly than before. That's the conclusion researchers made after combining data from different sources, including the U.S. Geological Survey's Mineral Yearbook and global records of river compositions and salinity measurements. The main factor bringing about these changes is salt mining for food and other products. Then there are also acid rains. Those increase the rate of rock weathering. These and other factors speed up the generation of salt at the surface of our planet. At the moment, the concentration of salt in the world is too high. The soil, plants, and animals can't use all of it. Even worse, some essential species can't survive with all this extra salt. Their demise changes biodiversity and can lead to the appearance of invasive species, such as phragmites. Those are tall, reedy plants taking over coastal areas. Then, there's also zooplankton, an important ocean species regulating algae. It's extremely sensitive to salt. If this species starts to decline, it might mess with the world's food webs. Too much salt also turns farmlands into wastelands. Recent reports have shown that around 833 hectares of land are already affected. And that's the area around 4 times the size of India. In some countries, huge areas become infertile because of oversalination. Plus, excess salt is bad for our health. The thing is, all that extra salt gets into groundwater, making it too salty for human consumption. It's particularly bad for people with sodium-restricted diets. And I'm not only talking about table salt or sodium chloride. No, other calcium and magnesium-based salts are seeping out too, usually from the production of fertilizers and building materials. It's like a chemical cocktail of different salts coming from various sources, and scientists don't know yet the effects such a cocktail can have on us humans and our health. So, maybe now you're sitting and thinking, oh, it's time to cut back on my salt intake. Perhaps, but don't cut it all out. In the 1930s, Dr. Robert McCants from Cambridge University's Department of Experimental Medicine found 4 volunteers and asked them to go 10 days completely without salt. First, they had to sweat out the salt that still remained in their bodies, and after that, the scientists literally desalinated everything they were allowed to eat and drink. Soon after, the participants started to experience weird sensations. They realized that they didn't taste much flavor in anything they consumed. It got worse. Fatigue set in, and the volunteers soon got too tired to even eat. They began to show the signs of hyponatremia. It occurs when the concentration of sodium in your blood is dangerously low. And that's when a person's blood cells swell because there's not enough salt in the blood to regulate how much water a cell should and will consume. If this condition is left untreated, it can not only result in seizures, but also have much, much worse consequences. At the end of the trial period, participants got some salty foods, and miraculously, within a few minutes, they could taste again, and their energy seemed to be replenished almost immediately. Honestly, it sounds kinda terrifying. If that's what a mere 10 days without salt are, imagine what catastrophe it would be if salt just ceased to exist. We wouldn't be able to last long, that's for sure. And it would be a never-ending drama, not only for us, but for plants and animals too. They need salt as much as we do. If our oceans suddenly lost all the salt, it would wipe out all underwater algae, cutting photosynthesis on Earth almost in half. Land-based plants would follow suit. So, soon after the disappearance of salt, we'd face a huge issue. Too much carbon dioxide and not nearly enough oxygen. Our climate would start fluctuating between extremely hot and cold temperatures, and hurricanes would become insanely powerful and super destructive. Luckily, we still have salt at our stores, and the natural salt cycle might get more or less stable again. By the way, humanity has known of and appreciated salt for many centuries. For example, it was used as offerings and to preserve mummies in ancient Egypt. It was a valuable commodity traded between the Phoenicians and their Mediterranean empire. In ancient China, people knew of more than 40 types of salt and used it for medicinal purposes. In medieval continental Europe, Venice gained power through its salt monopoly. The production and transportation of salt led to the appearance of new cities and the construction of roads. Salzburg, the city of salt in Austria, is a great example of that. Even these days, salt continues to surprise us. For example, recently, researchers from the University of Miami Rosenstiel School of Marine and Atmospheric Science have discovered rare deep-sea brine pools in the Gulf of Aqaba. That's a northern extension of the Red Sea. Those salty underwater lakes are likely to hold secrets about the way oceans on Earth formed all those millions of years ago. They might also give us some clues to life on other planets. Brine pools are some of the most extreme environments on Earth, and still, despite their ultra-high salinity, somewhat exotic chemistry, and total lack of oxygen, they're teeming with life. Researchers have even found bioactive molecules with potential anti-cancer properties in brine pool microbes in the Red Sea. These super salty zero-oxygen brine pools are located close to the coast and might preserve information on tsunamis, earthquakes, and flash floods that took place in the Gulf of Aqaba thousands of years ago. Salt has even made its way into space. Well, kind of. You see, the moon is like a comet soaring through the cosmos. Our natural satellite is followed by a slender tail consisting of irradiated matter, and our planet passes directly through this tail once a month. Well, according to a study published in the journal JGR Planets, this lunar tail is made of millions of sodium atoms. And as you already know, the chemical formula of salt is sodium chloride. Those atoms get blasted out of the lunar soil by meteor strikes and then pushed thousands of miles downstream by solar radiation. For several days a month, when the new moon is located between Earth and the Sun, the gravity of our planet drags that sodium tail into a long beam, which wraps around our planet's atmosphere. The tail itself is harmless and invisible to the unaided eye, but during those new moon days, high-powered telescopes can detect the faint orange glow of sodium in the sky.
A piece of whale rib has recently been found in a North Carolina mine. Not a big deal, some might think. Hey, why can't a whale be a miner, right? But this fragment offers scientists a unique glimpse at the interactions between prehistoric sharks and whales from around 3 to 4 million years ago. The thing is, 3 tooth marks embellish the rib. That means that the whale was once badly bitten by an animal with a super powerful jaw. Judging by the spacing between the tooth marks, and it reaches almost 2.5 inches, this animal could be a mega-toothed shark. I'm talking about the megalodon. Or it could be a different shark species which was around at that time. The curvature of the shark's jaw shows that the animal was relatively small, between 13 and 20 feet long. Yeah, small. As for the whale, it seems to be the ancestor of a great blue or humpback whale. Researchers are amazed. You don't usually expect to find evidence of animal interaction and behavior preserved in the fossil record. After examining the sample carefully, they concluded that the shark must have gone away with a mouthful, but the whale had survived because most of the fossil fragment is covered with what is known as woven bone. It quickly forms in response to localized infection. Such bone isn't particularly strong, and later the body remodels it into compact bone tissue. But it takes time. The presence of this bone means that the healing was incomplete and the whale passed away 2 to 6 weeks after the unfortunate encounter. On the other hand, its demise could have been unrelated to the infection and injury. Only a handful of fossils show such kinds of interactions between ancient animals. You can often find bite marks on fossils indicating where the animal passed away and its carcass was scavenged. But this fossil is one of a few examples that not only show a wound inflicted by another animal, but also demonstrate that the prey survived. All fossils are exciting for paleontologists. Yes, they need to get out more. But some might look terrifying to regular people. For example, look at this picture of tentacle arms and octagonal-shaped heads. When it first appeared in mass media, internet users claimed that it was some ancient organism that had come from space. Others thought the story was fake. But in fact, both the picture and the fossil are real. The fossil is known as a mortality plate, a fossilized representation of a mass extinction event of one or several species. The fossil actually contains more than a dozen specimens of a type of marine organism called a crinoid. Despite their looks, crinoids were not plants but marine animals. This particular species lived deep underwater on the seafloor. Crinoids were related to starfish, sea urchins, and brittle stars. These creatures could attach themselves to the seafloor with stalks made up of flexible porous discs connected by soft tissue. The stalks were hollow, and that's where the animal's nervous system was located. Crinoids absorbed oxygen through thin-walled tube feet. The creatures usually reached the length of more than 8 inches and had 5 arms lined with leathery-looking tentacle-like structures. They fed on plankton and sloughed off organic material. Now, even though these fossil finds seem to be super exciting, few creatures in the fossil record confuse scientists as much as the Tully monster. This curious sea creature sported a toothy, trunk-like snout and eyes splayed out on a rigid rod. But the most bizarre thing? It has been impossible to classify. Researchers have been considering a variety of organisms, for example, segmented worms, swimming slugs, and primitive eel-like creatures, since the monster was discovered in 1966. Recently, they have even tried to connect it to some species of jawless fish with a backbone-like structure. A team of scientists from Japan has used high-resolution laser scanners to examine the anatomy of Tully monster fossils in 3D. They concluded that the enigmatic fossil might be an invertebrate after all, and still, the true identity of the creature remains elusive. In the 1950s, amateur fossil hunter Francis Tully found a ghostly imprint of a torpedo-shaped organism with a huge tail fin in the Mizon Creek fossil beds in Illinois. Tully had never seen anything similar to the torpedo structure. He took his find to Chicago's Field Museum of Natural History. Paleontologists working there were baffled as well. Since then, scientists haven't been able to determine where the creature fits on the phylogenetic family tree, or where they should spend Thanksgiving. In 1741, an explorer and captain named Vitus Johansen Bering led an expedition to map the coast of Alaska. The ship he was on got shipwrecked on what later became known as Bering Island, and they got hungry. Half the crew survived thanks to the discovery of an extremely large sea cow. With the meat of these animals nourishing them, the sailors managed to build a small ship from the wreckage and return home. On their way back, a scientist who was among them spent his time documenting the animals and plants they had found. The sea cow was particularly interesting because without it, the crew wouldn't have survived. These animals were more than 26 feet long and weighed around 10 tons. All sea cows are members of the order Sirenia, marine mammals more closely related to elephants than cows. The scientists described them as having black skin, a small head, and stubby forelimbs. Those sea cows floated on the water's surface, munching on kelp. After the information about these animals became widespread, sea otter fur trading expeditions made use of that convenient depot en route. Sea cows were docile and could be easily hunted. Long story short, within 27 years after the scientists mentioned those animals, they were driven to extinction. But it's not the saddest part. The fossil record reveals a much deeper and darker history. Fossils of sea cows have been discovered all over the world, from Japan to Mexico. It means that the animal once thrived in the vast kelp beds around the entire North Pacific Rim. That small population discovered by the expedition was probably the last remains of a once much larger and way healthier population. More likely, Aboriginal hunting had already reduced the numbers of these animals to near extinction levels, and the final blow came from Western hunters. The living close relatives of those ancient sea cows are rarely hunted today. Still, they're under threat of extinction themselves. To some, this amazing fossil might look a bit disturbing. Slaves' lentils are fossils that belong to animals called nummelites. They lived and thrived in a warm, shallow sea covering part of Egypt around 40 million years ago. The name nummelites hints at the fact that larger specimens resemble coins, and in Egyptian folklore, they're even referred to as angel's money. These creatures have a simple, single-celled structure, which contrasts with their super intricate skeleton. Look at this series of spiral overlapping whorls. Each whorl is divided into countless tiny chambers. Nummelites can grow to be 4 inches in diameter, and still, they are the fossils of single-celled animals related to amoeba. How and why did they grow to be so large? The reason could be their symbiotic relationships with other smaller organisms. In the case of modern species, such symbionts are tiny golden-brown single-celled algae called diatoms. The shells of nummelites are relatively transparent, and since they're flat, there's a large surface area for the light needed for the diatoms to photosynthesize. For some reasons, scientists are still debating about them. The presence of plant symbionts and animals dwelling in the sea encourages the growth of a calcareous skeleton in hosts. So, the gigantic size of the nummelites in Egypt could be due to their close relationship with symbiotic diatoms. Does that make sense? Fun fact: a species of nummelites evolve very fast, and their fossils change from one layer of sediments to the next. So, the limestone used for the pyramids of Giza are so packed with such fossils that it's known as nummulitic limestone. This limestone also contains two kinds of nummulites, the smaller slave's lentils and the larger angel's money. But those are not different species, but rather different stages in the life cycle of a single species. Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide or simply DMS in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet. playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean, with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b, because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect